Hello everyone, in this video we'll see how to connect to ICM42688 IMU sensor to the STM32F103 microcontroller using both SPI and I2C interfaces. We'll also configure the necessary pins in STM32Cube. Additionally, we'll go over the schematic design and examine the PCB layout. On this board, you'll see how to integrate both communication protocols for the same sensor. So, you will learn how to implement two different communication methods on a single design. We start by defining the necessary pins in STM32Cube. Next, we configure the clock settings. Save the project with Ctrl S and generate the code. Everything works smoothly at this stage. We begin the schematic design with the microcontroller and USB-C connection. We make the basic connections for the STM32F103, including the coupling capacitors, the boot button, crystal oscillator, and required pins. We connect the D+ and D- lines to the corresponding USB pins on the microcontroller. CC1 and CC2 pins are pulled down with 5.1K resistors to ground. We also connect the V-bus and ground lines. Next, we move on the I2C connection of the IMU sensor. Using the datasheet as a reference, we design the schematic accordingly. We then review the SPI connection, which is also straightforward as shown in datasheet. This allows us to use both I2C and SPI protocols for the same sensor on a single board. We are using AM's voltage regulator on this board. We add 22 microfarad capacitor to both the input and output pins to ensure stable operation. The ground pin is connected to ground. A resistor and LED are added to visually verify the 3.3 volt output. Thanks to this regulator, we convert the 5 volt from USB to 3.3 volt, which powers our system. To program the board using SWD, we include a connector for the ST-Link, and we have a mounting hole. Now we move on to the PCB design. The board is two-layered and measures 42mm, 37mm. We remove all polygons to get a clearer view. In the regulator section, we use white copper areas, polygons to help with heat dissipation. The voltage pass line from USB passes through capacitors and the regulator to output 3.3 volt. This 3.3 volt line is then distributed to the rest of the board. You can clearly see the I2C and SPI connections for the ICM sensor. The SPI connection includes a jumper wire, but it's not a major issue. I use multiple ground vias throughout the board. This helps with both thermal management and reducing EMI, electromagnetic interference. After repairing all polygons, the PCB layout is complete. We take a look at the 3D view of the board, both front and back. We also changed the board color for a cleaner look. Thanks for watching up to this point. Please leave your feedback or suggestions in the comments. If you notice any mistakes, let me know so we can fix them together.